I put these instructions up earlier. So if you were here, you might have already done it. Did anyone run into problems? OK, or you just don't want to admit, but that's fine. OK, who has like got the repo and the conda environment, so they're good to go? OK, I would say it's just under half. That's actually better than I expected, to be honest. So I think we'll just go with it, and we won't waste too much time. If you can't download it, you could just follow the notebook online. So if you go to the repo, you can click there. And there's enough instructions that you can just scroll through. If any of you have, like, if you really want to follow along and you're having a specific problem, then maybe, yeah, just like stick your hand up.
Yeah, I'm actually the technical guy here. He'll do the smart stuff. I'll kind of help with more engineering stuff. So, yeah.
You might have problems if you're on Windows. I don't know. I don't have much knowledge of that. All right. So the way it's laid out is that if it's quite simple and you're already a complete pro with like pandas, for example, because now you went to Kung Fu Pandas, whatever it was this morning, then you can just run ahead through the notebook. That's fine. And we'll kind of do, what a squadron would do and go at the speed of the slowest man. And so the slowest person in the room. And feel free to like run ahead. And then there's sort of an advanced notebook, and you can fiddle around with some of the data. I've given you like a large data set to play with. So if any of you get bored and you want to do some analysis on that, then we could feed back at the end, and you can tell us if you found something. I didn't really have time to fully go through that, so there could be something interesting. So I'm going to get rid of this now. Is that all right for everyone? OK, cool. So who already knows pandas pretty well? OK, nice. So we might actually blaze through the first part. And scikit-learn? OK, reasonably good. And sort of like some rudimentary machine learning theory, cross-validation, training testing sets, this kind of thing. OK, nice. And NLP. Let's try that one. OK, so this is good. So some of it might be new for some of you, some might not be. So OK, we'll see how we do. I'm just going to grab the repo. I wanted to make sure I do it fresh so they're all at the same point.
Can you put the previous instructions up again?
Yeah, no problem. So actually, you can follow along with what I'm doing here. I'm going to do the exact same thing. Oh yeah, I was going to say I'm going to do the same thing here. So you can follow along here, all right? Can everyone read this? Bigger? Who asked? Is this a suitable replacement? Whoever just asked that? It's not a suitable. Oh, if you want a photo, I see. All right. OK. So you just go into here, and then if all goes well, the end of create, that's it, isn't it? It's going to install your environment for you. OK, while this is going, I'll just talk through what we're going to do. We're going to do some pandas. We're going to load up some data. So I've labeled some data for you. And this is something I got from a news API. You can go to newsapi.org. It's free to use. And it's sort of like a live stream of news from various sources. You don't get the full content. You get the title and a sort of summary sentence. So we'll have a look at that. And there are some instructions in the repo if you wanted to grab your own API key. And you could get the data yourself. So I scraped it for a few weeks. And then at some point, while watching TV or something, I just went through and labeled it all. So I've done the hard graft for you. So don't complain if the labels are poor. All right. So the starting point is that you load the tutorial notebook. Probably a few people are already at that point. Everybody here? This looks familiar. You've already seen it on your screen. OK, cool. Is that a good size for everyone? Is that clear at the back? You can see the code. OK, to be honest, there's not much code to fiddle. So the idea is that we're just going to execute stuff. You could fiddle with some of the cells to as much as you like. But the main content is already all there. So you can just shift-enter, and we'll work down together. But if you have any questions at any point, just stop me, and we'll go whatever pace you guys want to go. We can skip some sections. We can go over things time and time again. So please interrupt. Otherwise, it's going to get probably incredibly boring just watching me shift-enter on this, OK? So the CSVs should already be there. So if you load the first couple, we'll use pandas to load up the CSV. So since, we can always think of this as from the sort of client perspective, or if we were doing this for someone, so we're providing some sort of service, you very often are given a CSV, particularly if they're not that technically minded, you might even get an Excel file that you have to dump yourself. But that means it's going to be in a tabular format, and pandas is, of course, the way to go. This uses objects to represent everything as tables, and it's pretty great. So what you've got here, each line is an article. It has an author. It has a title and a published at date, which apparently is sometimes not there. And then a label. So a 1 means it's clickbait, or I determined that it was clickbait, and a 0 is news. It was actually quite hard. I was labeling some Daily Mail articles, and it's like, do I count? Sometimes I thought that is definitely clickbait. That doesn't feel like news. But for some people, I don't know, like someone having a toned stomach on a catwalk is like actually relevant news for them, maybe. So I had to refrain from saying that like Kim Kardashian news was clickbait. That was apparently relevant. So you might debate what I've done. I don't know. OK, so df.head just gives us a quick overview of the data. That's a really good place to start when we've been handed a CSV, And let's go down. We can just have a look at an example. So the title of it, this is textbook clickbait. This is such poor English. Literally just 19 pictures that prove hedgehogs are ridiculously cute. So this is exactly the kind of stuff we don't want to see. This is prime clickbait material. So in case you had any doubt what clickbait was, coming into this, hopefully, this is the sort of thing you've seen on Facebook or social media. You kind of know now what we're talking about. Not that you ever needed convincing of their cuteness, TBH. So there you go. So we'll do some really quick panda stuff. And I'll go through this because I think most people said they've already used pandas, right? So we can grab the label column, and we can just do value count. So we can see we have 808 articles that are news and 557 that are clickbait. This is actually quite nice because it's a reasonably even distribution of labels, which is going to make things easier for us going forward. Now, the thing is with pandas is that there's quite a lot of functionality, but I find that no, you just have to kind of keep using it to eventually learn what the functionality is. And so much of it sort of chains together. So I find like eventually you end up writing these really long lines.
Can you just increase the font?
Yeah, thanks, Andraz. How's that? Good? OK. So similarly, we could get the author field, and we can figure out how many none values we have. And you can also add plots. Again, I think that was in one of the workshops this morning, or maybe most of you already know. So you can think of it step by step. We grab the author column. We count, or we basically, if the author is null, there will be a 1, otherwise there will be a 0. And then we just count the number of true or falses there are, and then you just call plot on it. So we get a horizontal bar chart that shows how many were null and how many were false. All right? So there's not much information there, but I just wanted to give an example of chaining these calls together and some plotting. Something else we can do is we can apply functions. So here, the description column, each entry is just a string, right? And so we can apply length to that, and it will just tell us the length of the string. So if I remove this here, so that's the number of characters for the description string for each article. And if you do mean, we'll just get the average length. So we can see, OK, that's the average length, or the average number of characters in the description string. OK, we're kind of getting some insights there now. So if you can imagine if this was big data, if this was some huge database you're querying, you already have a sort of rough idea of what the data looks like from a really high level. So from this, we can see, OK, so description is probably just a sentence or so telling us a little bit about the article. Of course, I cheated. I already know exactly what that string is. And then here, I've done the same line, but after I've grabbed the descriptions, I've computed their length, and then all I've done is I've added this group by. And so what this does is we have this column, which has the length of every field, and we're just going to split that out into 2 columns based on whether they're clickbait or not. And then we just compute the mean of each of those. And now we start seeing something quite interesting. So we can see that the descriptions for the news articles are, on average, longer than the clickbait ones, which is kind of right. This is the sort of style of journalism you get, right? So if we pull something from the Financial Times, probably that sort of leading sentence is going to be quite convoluted, whereas BuzzFeed might say ridiculously cute, TBH. So I think that makes some sense. Okay, well, I'm going to skip over this. And something else that's really cool is if you're familiar with NumPy, is that it also does broadcasting. So you can just add two columns together, and you can. So here I'm going to grab all the descriptions. I'm going to add a space and then add the title. And so we can sort of really quickly build a. Well, you can't quite see actually that that's the full content. So I've created a new column called full content, which we just concatenated the string and the description. All right. There we go. Trust no man, trust no brand. So we put them together. And later on, we'll use that. But I just think that this is really nice in pandas that you can just stick these two things together. Yes?
Why does that group by work? Because the thing before gave you a series that no longer has that column called label.
Yes. So you're probably more familiar with the pandas format where you like group the frame.
I would have done it the other way. I would have grouped it by and done something else. It's terribly complicated.
Yeah.
But why does that work?
So you can call group by with any. So as long as it's the same length, you can have a sort of indicator. And so in this case, we actually pass it the labels. So because the labels column is the same length as that sort of length of the descriptions, if you imagine.
Oh, it's an indicator function.
Yeah, so it's like an indicator, and so it bins it based on that. And that's I actually figured that out whilst doing this workshop, because often if you group by and then apply, it's going to do something slightly different to doing it the other way around. Otherwise, you kind of have to make an intermediate column at some point. But yeah, okay, good question. I recently discovered it, and I actually found it really helpful since. So, yeah, you can use group by with any arbitrary thing. All right, I thought we'd go slower up to this point, but I think everybody's following. So I put this in to remind me to stop and take some questions. So is everybody clear so far? Nobody's outrageously lost? Okay, good. Let's do something more interesting. So I just thought I'd go into some scikit-learn terminology before we get fully stuck in. So a transformer is a kind of function where in one end it takes some data and then it applies some manipulation to it and spits data out in like another shape or another format out the other side. So that's it. And usually they have a fit method. So when we fit a transformer, then it basically looks at all of the data we have available and figures out how it's going to transform our data. There's some parameterization happening. That'll become clearer when we look at a specific transformer in a minute. And then you have a transform function. So once it's figured out how it's going to transform your data in a useful way, then we can feed it any data in there, and it will transform it into the same output. It's nice. It saves us writing a lot of code, and you'll see that in a sec. And then a classifier, I'm sure if you're familiar with basic machine learning terminology, then the idea is that we take a sample, so like we look at an article, and we just want to put it in one of a number of bins, and we want to do that algorithmically. So in this case, the two bins are clickbait or news, clickbait or not clickbait. So that's all that's going to do. And then a pipeline is a really nice abstraction that scikit-learn provides, and they provide the whole interface for this. And you can string together sort of blocks of transformers in a row and then put a classifier on the end. And they're brilliant because what you can do is you can have this reproducible pipe that's in one object, and you can always put the data in the same shape in one end, and you'll get a prediction out the other. So often someone gives you some data, and you have to do lots of transformations, right? Or you need to merge stuff together. And what you can do is you can save all of those transformations in kind of reproducible steps. So someone always gives me a CSV that looks like this, and it has these columns, and then I turn it into this sort of numerical data, and then I manipulate it this way, and then in the end I classify it. And so it's kind of like you have a recognizable input and output, and you don't have to think about those kind of weird intermediate stages. That's the benefit. So let's talk about a transformer. When we have text data, and this is where if you're an NLP guy, this is your turn to be bored, or if you already know this. But our classifier isn't going to be able to work with raw text data. It's not that useful. So what we need to do is turn that text somehow into some numerical data that we can use for our classifier. And the typical way to do that is the bag of words model. And it's very, very simple. So you imagine you have a sentence, you chop it up into words, which are sometimes called tokens. The reason for that is that punctuation can also be a token. So a token could be and, the, Craig, or it could be comma, exclamation mark. So we split our sentence up into a bunch of tokens, and then you just count how many of each one there is, and that's your data. So in this case, we have literally just 8 really, really cute dogs would be transformed into this, right? So cute appears once, dogs appears once, just once, and really twice. The downside is that we lose all of there's no information on how the words are ordered together. It's just, you just know the sort of frequency, so how commonly the words appear, or if they don't appear at all. So you kind of lose any semantic reasoning that's in there, and you also lose the ordering, which is a shame, but it's very simple to use. And the other important thing we're going to do is assign a numerical ID to each word, and this is called the vocabulary. So all we do is when we fit this transformer that we're going to use, which is called a vectorizer, because it turns your text into a vector. When we call fit, it looks at all of the words that we have in our data, and all it does is assign a unique, or all of the tokens, it assigns a unique ID to every single one of those. So that in future, you just say, OK, and is ID 53, and it appears 3 times. So you're going to have a vector, and a number 53, which corresponds to and, a 3 will appear. Does that sort of make sense? So we end up with words going in, and actually the output, maybe I could have made this clearer, is these 2 columns. So you end up with a vector with indices down here, and then the number of times that those words appear. All right, so it's purely numerical. So we'll do it here, and it's all in scikit-learn. So if you run the cells with me, we'll create a vectorizer. This is called a count vectorizer. And I'm just going to fit, for clarity, this sentence we looked at earlier. And then I'm going to print out the vocabulary, right? This is in the vectorizer. And you can see we've got a dictionary. And so for every single word that we've seen, each one has a unique ID. So now we stop thinking of words in a textual sense, and we start thinking of them as tokens with just a numerical number, which makes it kind of difficult to introspect later. But this is how the algorithm is going to handle our information. And so what we can then do is we can transform a new sentence based on this vocabulary we've learned. So I could do literally 5 cats. OK, so do you see what has happened here? Is that the vocabulary is fixed on what you fit it to. So each one of these elements here is, so this is literally, which is at number 3, so 0, 1, 2, 3. This corresponds to literally, and it's appeared once. But 5 and cats was never in our original vocabulary. Okay, so we're limited by the training data, which makes complete sense. So this is a very contrived example, but really you would have like a big corpus of documents, and you'd feed them in, and you'd learn all the words in there. But then if you send your classifier into the wild, as I often end up saying, and it sees some words that it's never seen before, then it has no reason to base any predictions on that. So they're just ignored. Okay, so your vocabulary is fixed based on what you've seen in your training data. OK, I think I just did the same thing here. Right, yeah. Also, a good reason to use Python 3 is that Unicode is fully supported. So you can train on emojis. I'm pretty sure scikit-learn uses this all the way through. So an emoji can be a feature. That's completely fine. And so I just gave an example here. It's ignored. Maybe we should have trained on it. I don't know. Can you do that? Let's try. I think maybe it's because, so this vectorizer, if you're already, is everyone following along? This is good? No one's like really lost? OK, I see lots of nodding. Lots of nodding, yeah. Oh, it's a fit. Oh, yes, good point. Let's try that. Maybe that was it. No. I think it's because, so let's remember in Jupyter you can always put a question mark after a method or an object. It tells you about it. The reason is that the tokenization, so how we turn a string into a bunch of individual tokens, is based on this regex. And if you're a regex pro, you'll see that that's not going to capture Unicode escape characters. It just looks for word characters. But you can actually write this however you want. So you could pass in your own tokenizer, or you could use, I think there was a talk on GenSim earlier. So they have their own tokenizer functions. And so you could even use something from another package and use it in scikit-learn. That's perfectly fine, as long as it takes a string in and spits an array out. So there it is. So that's why the Unicode doesn't work. Sorry about that. I was actually quite excited to train on an emoji, but another time. All right, let's go into classification. What time do we finish?
I think around 3. No, around
3:30? 10 past 4. My goodness. We'll slow down. I mean, there's lots of material to come. We'll make it up at some point. And maybe you won't notice the transition when that happens. I don't know. So let's go into a bit of detail on the classifier. So we're going to use a support vector machine because it's very simple and it's fast to train. And we can introspect it later. So here's a textbook classification task. And we'll always try and think of this in terms of words an NLP and the clickbait problem, so that we don't lose the context. So you can imagine our vocabulary is just 2 words. So I don't know, a sentence is always just made of cat and dog. So everyone's talking cat, dog, 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 cat, dog, cat, cat. And so when we put it through that vectorizer, the output is just the number of cats and the number of dogs that appeared in the sentence, in the document. And so you can imagine we could plot them just like this. Can you see? The mouse is a bit small. I'll point. So you can imagine, if there's a lot of dogs on this axis and not many cats, you end up here. Whereas if you have a few dogs and loads of cats, you're sort of up here. And if you have lots of dogs and cats, then you end up in this corner. And so the idea is that you have in this space some sort of clusters. So I suppose, given the example I've just said, I guess these would be like animal lovers. They're always talking about cats and dogs. And down here, they're not really talking about either. Maybe I should have split it another way. So you had the people who love dogs and love cats. But there you go. So these people say cats and dogs a lot. And these people don't say cats and dogs. And so I've labeled the 2 classes. So we can imagine that this is sort of like clickbait or not clickbait. This is a very simple example, but the concepts are the same as you go to multiple words. So in this case, we just have 2. And what we want to do is we want to find this separating line. We want to optimally find a line that describes the split in our data. And the reason we want that is because later on, if I come along with a sentence that has, I don't know, this many dogs and this many cats, this isn't a sample we've seen before. But we know that because it lies on this side of the line, that it belongs to this class. It turns out I loved animals.
Are you suggesting everything above the line is clickbait?
Yeah, so, I mean, it could be any class. But yeah, for example, this could all be clickbait, and this could not be clickbait. Yeah, so that's the idea. And so then if a new article comes in, we just figure out which side of this line does it lie on. And so the idea of the classifier is we just want to learn where that line is. That's all. In real life, we have a huge number of words, if you think about the size of the English vocabulary. So it's not 2D. So you have this very high dimensional space. And rather than finding a line, you're looking for this optimum hyperplane, all right? If you prefer mathematical speak. That's what we're looking for. Notice as well is that we don't have to have what's called linearly separable data. So you don't need your samples to be completely on either side of the line. The SVM optimizes itself to find a sort of ideal minimum. And we can actually control that in some way, which we'll see later. All right, is that clear? Everyone's clear on classification? Great. Moving forward. Again, scikit-learn already has that. Would you believe it's almost as if we base this on scikit-learn functionality? Scikit-learn has the SVC. And so here I've just done, again, we're really doing this in a simple way so you can see the underlying mechanics. We're not just going to show you the interface. It'd be great if you guys really understand what's going on under the hood. So here I have 1, 2, 3, 4, 5, 6 samples, right? So this might be the output of our vectorizer. We had 6 sentences, and in the first case, there was 1 cat and 6 dogs. They were the words in it. In the second case, there was 1 cat and 4 dogs, and so on. So this is our vectorized text data, okay? And then I've just assigned a label. So let's say this is clickbait, 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 and these 3 aren't, okay? So if you execute that, I wrote a little script just to plot it. So okay, this looks like what we had before, right? But now you can see it with some real numbers. So we have some samples down here. So imagine this x-axis is dogs again. So these people are talking about dogs much more than they are cats, and cats much more than they are dogs. Does that make sense? So we see 2 very clear communities of the cat lovers and the dog lovers. And we want to find the separating line between those optimally. And that's all the SVM does. So all we have to do is go to our SVC, support vector classifier object, and we just call fit with our words and their individual labels, and then you can just plot that here. And that's what it did for us. So it figured that out itself, and now we've reduced all of this data to just this single line. You know, if you showed this to someone, you wouldn't even have to show them these points. You just say, this is how we separate the dog lovers from the cat lovers. So if someone comes in and they mention cats this many times and dogs this many times, we know they're more on the dog side than the cat side. Is that clear? OK, cool.
What happens if it's not linearly separable?
OK, yeah, so it does still handle that case. And the way it does that is, so the first thing that the SVM looks for is to maximize. So you define this thing called a margin, which is the distance between your line and the sort of opposing classes. So of course, you want that to be as fat as possible. because the wider the margin is, the further you are from the two. So that makes sense here when they are linearly separable. But you basically penalize it. I don't know, are you a mathematician, engineer? Okay, so if you are, it's like a Lagrange multiply problem. So that means you basically make that as wide as possible. So you choose the line so this margin is massive. But if stuff crosses over, then it kind of gets penalized. You have a score function of some sort, and that score goes down the further. So if you shift this all the way over here, you're going to have like two lines across, and so the score is really poor, and so it will kind of move around. And the trade-off between making that margin as wide as possible and misclassifying, there's a parameter we can tune to choose like which one of those we prefer.
But you just have to kind of pull it yourself or something. It doesn't kind of explode and say this is a really bad model.
No, it will always put one there.
It will
So
always give you one, right?
yeah, it will. Yes,
Sounds check it yourself.
absolutely. Yeah. And that's why actually it's always good to just plot your data first. I mean, if it's 2D, you can. If it's 10,000 dimensional, you're going to have a hard time. Yeah. But yeah, this is a really good point. So always try and visualize your data. There was a really good talk, actually. Since we have time, we'll just quick. Did anyone see that? It was maybe someone remembers the website it was on. They showed this 2D plot, and it had all sorts of different shapes on of data like this. So it was two classes. And it showed the variance on one axis and the variance on the other. And sort of in all cases, you had, yeah, so someone has seen it. I think maybe even PyData tweeted about this. Is that the one? Oh, yes, that's the paper from the 70s. And yes, that is the one. Here you go, look, I can get it right here. I think this is actually worth the detour because, okay, they're making me sign in. What was the name? O-M-P. Like that? A-N-S-C-O-N-P-E. And I think it was these guys who came up with a cool animation for it. Oh, does it? Maybe it's the same one. Okay, let's try. I did not think I'd be going on Wikipedia during this workshop.
You're talking about the one with the dinosaur, right?
Yeah.
Yeah, it's the first.
It's the Autodesk one.
Yeah,
Okay. So I just think based on the comment that was just made, this is really worth looking into. So look at this. So this is data distributed in different ways. And okay, this isn't the full effect, but I'm not going to bother going much further. But they basically show that the mean of the x and the y data, as well as the variance in x and the y coordinate, and the correlation, is the same to 3 decimal places for all of these pictures, right? So the main message is that you shouldn't rely on just sort of numbers, on accurate statistics all the time. So definitely always sanity check. Because you might think, okay, there's obviously a clear correlation here, and you just end up that you have a dinosaur face and somebody trolled you. So I don't know, I think this is really insightful. And I'm glad I had an opportunity to share it, because I kept wanting to tell some people about it.
So, just one more question, quick one.
Yeah.
So given you can't visualize something that's in 100 or 1,000 dimensions, is there just a number like quality of fit? Like, 0, I just can't fit a line to this that means anything to 1.
Oh, I see. Okay, yeah. So there are ways to look into it. In particular, there's a probabilistic version of the support vector machine as well. And it'll basically show that there's a very poor probability that this is a good fit. You can look at the size of that margin and things like that. So yeah. Plot your data. That's important. And of course, if it's 10,000 dimensional, that's an open question. And if any of you have some cool ideas on how you can do that, I'd definitely be willing to hear how it's done. So there you go. Okay, that was a really nice segue. More of those, please. Okay, so we found our line. Let's go back to where we were. We found this line. And so now imagine we see 2 novel samples. So we've been shown 2 word counts samples that we haven't seen before. You can go up. We haven't seen 3 and 1 and 2 and 4 before. And then it will say, OK, this first person was a dog lover and the second person was a cat lover, for example. Clear? What the classifier does, why we do it, and how it works with the vectorized text data. All right. So you see that was all in 2 separate steps and was a little bit convoluted. OK, I'm not going to go through this now. But if you want to sort of scroll through the notebook yourself, you can learn a little bit more about how the pipeline works. But it's just important to note that this pipeline object contains your transformer, so that vectorizer and the classifier all in one. So then all you have to do is stick your training data and labels in one end, the pandas data frame, and it will train it, so it will figure out that line, and it will work out the vocabulary for you. And then later on, all we do is pass in some new novel features that we would like to classify, some new documents we'd like to see. Again, just in the format that they are in the CSV file, and then it's going to spit out labels. So this is the benefit of the pipeline, is that you have this fixed. So we've already decided on the structure of this. It's fixed, and all we have to do is CSV on one end. Well, once it's been loaded as pandas, but CSV on one end and labels out the other end. It's that simple, which is great for your non-techie colleagues who would like to sort of play around with it a bit, but don't want to see too much code. This is handy. And the way you define that is also incredibly easy. You just have a tuple of tuples. So this is a name of the step in the pipeline, and that's completely arbitrary, so you could call it classifier, optimum line finder. You could call it whatever you wanted. But I've gone with vectorizer, and I've just created a new count vectorizer, and then a classifier, and a new classifier. All right? And then all we do is import pipeline from scikit-learn with the steps. And that's it. It's that simple. So that's a scikit-learn pipeline that has the vectorizer and a classifier after it. Any questions about the pipeline, how it works, anything like that? No? You just want to see the real data? Yeah, let's do that.
I have a question.
Yeah.
There's only going to be one classifier, and it's always at the very end.
Yes.
Versus there could be multiple transformers.
Yeah, so there can be lots of transformers with one classifier at the end. However, I think so scikit-learn has some like majority voting classifiers that take as an input a sort of bunch of votes for labels, and at the output produces sort of an aggregated label. And as its parameters, it can take more classifiers. So does that make sense? We don't have anything to draw on. OK, but you can imagine you have transformer, transformer, transformer. Then the input could go into 10 classifiers. And then you end up with the last classifier being a voting system. So they all vote, and whoever does it the most times. So yeah, it's possible. But I didn't show it. But the last step should always be some kind of classifier. All right, anything else? No? Good. So let's just talk a little bit about, and again, I don't want to patronize anyone, but I think this is a really important point if you don't know it already. And this is some really basic machine learning discipline that we should follow. When we're given some training data, you should always take a batch of that, which you're going to look at and you're going to use to improve your model, and a bunch of it you're going to use at the end to sanity check everything. And we call this the out of sample or testing data. And my supervisor once told me that he just puts it on like a USB stick and deletes it from his computer and locks it in a drawer, which I think is really extreme. But this is basically the sort of level of discipline you should show. So you could create your testing data and you lock that away. And as you sort of build your models and play with your models and test them, you shouldn't look at that. And then at the end of the day or at the end of the project, you can go and check how well you do on data that you've never seen before. And that's sort of as close as possible you get to the performance you might see in production. And so you're not going to put it in production and get wild surprises. I mean, that's so common. Even, often we need to move fast in a company and we don't have time to follow this. But if you're really thinking about it from the start, it's possible. Because you really want to minimize the surprises you get between training performance and production performance. So do that. And scikit-learn, would you believe it, offers a way to do it. Okay, so this is just called train test split. And so what I'm doing is passing df, if you remember, that's a poor variable name, but we're going to stick with it. This is just the data set we originally started with, the CSV. And then we specify that 70% of that we want for training. So we're going to split our data frame into two separate data frames. One is 70% of the samples, one is 30%. We also give a random state. So it's also going to do some random shuffling of the rows. The reason being is that often you have sort of like, so in this case, it's actually true. All of the clickbait is in one chunk, and all of the news is in one chunk. So if you sliced it that way, your training data is going to be like all clickbait, for example. So it's going to be absolutely terrible. So it shuffles up your data to make sure you have an even distribution of the classes, and then it splits it. And that shuffling, we kind of want to be deterministic. So if at the end of this, we find out where our accuracy is 80%, and then we give someone this notebook, because it's random, they might end up with a different statistic. And they're like, well, OK, I actually found out it was 75%, not 80, so what the heck did you do? But you can set the random state and say, always start the random number generator with this seed. So although it's random, every time you run the cell, you'll get the same result back. OK? So that makes sense, I think. Good. And finally, it's often quite a good idea to use stratification. So what this does is, if you imagine you shuffle all the rows, there's still a chance that you shuffle them and you put all the clickbait back together in one row and all the news back in one row. Unlikely, but of course, there's a chance. So stratification just ensures that the distribution of classes in the training and the testing set are exactly the same. So you just tell it, like, these are my labels, so please just make sure that my training and testing has the same proportion of clickbait and news in them. And then that way, again, we don't have a huge surprise when we move to testing. OK, so I'm going to run that. And then we can now look at so the output of that is one training set and one testing set. So from here on, we're not going to touch the testing, OK? Remember that. And so here's what our training looks like. You can see it shuffled, so the index on the left has changed. But otherwise, it's mostly the same. All right? Yeah, I've just seen it. So apologies if any of some of the news articles were scraped from Al Jazeera and things. I know that we're in times of political instability. So if there's something shocking, I do apologize. But it was just a live stream that I pulled down. OK. And so you can see there, if your maths is good, approximately a 70 to 30% split of data. And so we defined our pipeline up here. If you remember, we said that our first step is going to be one of these vectorizers. Now remember, these are untrained, so I just created new objects. So all we're saying is our pipeline consists of this vectorizer and this SVC. We've really said nothing about the parameters or any data. And all we do is call pipeline.fit, again, as we did before. And we're going to pass it the titles of all the articles in the training set and the labels. So all we're saying is, OK, here is a bunch of samples, and they have a string, which is the title. And then we can tell the classifier if it's clickbait or not. And it's going to turn them all into numbers, cast them into this huge high-dimensional space, find the optimum hyperplane, and then we have a way of predicting new samples. So we just press Shift-Enter on that, and it's done. That is it. And so now we can start predicting things. So you can play around with these as much as you want. So there you go, 10 things you need to do. I don't know why I did that. So 10 things. That's apparently clickbait. You could try, I don't know, seriously hilarious cats, OMG. Okay, that's also clickbait. But you could, for example, try something like to do with the French election. That gives you 0. We could try, OK, I'll be interested. French dog polls. OK, that doesn't change it. Sent only for Kimmy K. OK. OK, one thing I actually found whilst playing with this is that this is a very strong indicator of clickbait. Yeah, OK, that flipped it. So this is really interesting, right? If you think about journalism in general, like if you're a good journalist, you would never use this in sort of like there's no information in that as like headline. This article is going to blow your mind. Like that wouldn't be great journalism. So I think this is a very BuzzFeedy type thing. So if you want to avoid clickbait just in general, don't pick a title that has this in it. I also find that I think is quite predictive. So let's your French dog. Yeah, so that also works. So there you go. The Financial Times would not address the reader or say this. Yeah. So so here, so we have to initially. Sorry, go on. That was it. So further up here, you see that in order to find the separating line, we need to know that these are a certain class blue and these ones are a certain class orange. If we didn't know that, then we would just have like 6 points in this space, and we wouldn't really know where to start drawing any sort of line. I mean, if it was an unsupervised clustering approach, which maybe I haven't made clear this is different. If this was like a clustering approach, then you wouldn't have to have labels, and it would say, well, these are roughly together, so they must be something, and these are roughly together. But actually here, we're giving it more info. We're explicitly saying these are clickbait and these aren't clickbait. Does that answer the question? OK, cool. So we have to say, here's a bunch of samples, and it's whether they're clickbait or not. And whereas here, these are new samples that we've just invented, and we don't know whether they're clickbait, but we would like to know. So that's the difference between the predict. Is that clear to everyone? Fitting and predicting? Cool. OK, so let's. I've wrote a small script. This actually isn't in scikit-learn, but you can have a look at the functions that I wrote, and they're actually quite simple inside. So all this does is it looks inside the SVM and tries to figure out which words are the most important. So it shows these are the sort of top words associated with clickbait, so the things that tell us most that something is clickbaity versus news. And it actually makes a lot of sense. I was really surprised because the data set is relatively small, so I've given you about 1,500 samples, just under. And if you think about the size of the English language, I said that before, you're going to end up with this huge multi-dimensional space. And so 1,500 articles is not that many to find exactly what clickbait is. Remember, our vocabulary is fixed, so there are all sorts of words that we could see that we haven't seen before. So for example, it thinks 21 is really important. And that's actually true. You often see numbers, you see these lists like 5 hilarious hedgehogs. But I guess we would assume that 21 should be as predictive as 23, for example. But we haven't seen 23 before. So you can see we need a lot more features in order to do something useful. So I was really pleased with the performance. And actually, the support vector machine is actually quite robust, much more than other algorithms, to this really high dimensional space problems where you have not many samples.
So the function you wrote,
Yep.
did that basically find that these words were higher up, or there were just a higher count of them versus anything else, or were we doing something else?
Yeah, so it's actually based on their coefficients. So you can take out the model, the relative weight of importance of every single word. So what I do is I get all of the words that we've learned in the vocabulary, figure out their weight in the classifier, and then I sorted it by what is most weighted towards the positive class and the negative class. So you just look for the biggest positive coefficient and the biggest negative. So there it is.
Sorry, can I just add that that's a very nice library to see all the important from scikit-learn algorithms.
Oh, is that?
It's called L5, explain like on 5.
So if I do from, do you know roughly?
L-E-L-I-E-L-I.
That, ELI?
5. Yes, so I don't remember exact there's a function, but if you just search, there's a GitHub page.
Okay, great. So we can try that.
I just found it recently, it's really useful. Also to export text.
Mm-hmm. So very nice. So I was going to try and quickly find. Oh, this is related to the Lime guys. Okay, this is.
So it's an extension.
Let's segue again. Who's heard of Lime? Okay, great. So this was presented at NIPS maybe a couple of years ago now. Still highly relevant, despite what was said this morning in the deep learning. Of course, Lime isn't going to get me it, is it? Lime. Oh, I've tried this before. Look at that. So this is really cool, and this doesn't even work with support vector machines. This works with arbitrary, black box models, like a deep learning model or something. And what this does is, look at this great output we get. So this is great for showing colleagues or whatever, and you can show how productive you are. This, so what you do is you have your trained classifier like a support vector machine, and then you input into it like a new sample, and it shows you and it formats it. It does all of this formatting for you in the notebook. It shows you specifically which of the words are contributing to one class or the other. So for example, here they were trying to classify between atheism and Christian, I guess based on emails. And so they put this email in, and we don't know if the person or the topic or the content is atheist or Christian, but it determines which way. Actually, it's quite interesting that it looks like having a .edu email makes you more likely to be atheist. I leave that open to interpretation. But yeah, so that's quite cool, right? So yeah, if you want to introspect the models, whoever asked, you can go really deep with these kind of tools. They exist, but this is really also an open research question. So I don't know, if you're looking to do a PhD or something, this would be a really cool topic because it's moving fast and it's really interesting. And I think important to the field as well. Okay, nice work. And I'll look at Eli 5 or LE5 another time.
So what was that called?
That was called the Lime.
No, you said this topic. What is this?
Sorry?
What is this field known as? It's not NLP. Is it something within NLP?
I guess this is, I don't know what the motivation was here. If it could have been topic modeling, it could have just been a classification problem. Matisse, you know more about this example? It's just okay. So it's the same as what we're doing. That's the motivation. Okay, thanks. Okay, you can also do multi-class. Pretty cool. That's, yeah. Sorry? Oh, the utils plotting is just something I wrote. So that's in the the repo that you pull down, that's there, utils. Okay. I'm not moving too slow. People aren't getting bored. So I realize if you're not following along, this might be a little, okay. Or you're just too embarrassed to complain. I don't blame you. I'd be the same. Okay. So I'm going to move on in ignorance of how you feel about the workshop so far, and we're going to keep going. Okay. So the next thing we want to do is we want to figure out actually how well we've done. So we don't know that yet. We've looked at the features. We looked at the top words, and actually they've already filled us probably with a lot of confidence because they match our intuition. Again, really important. This comes back to the plotting. Let's always at each step think about what the intuitive answer is. Of course, unintuitive answers are usually the most important ones. They'll get you high up on Hacker News. But you need to be able to reason at least in some way. Otherwise, we start losing sanity in our models and confidence if we give this or sell this to someone, as you might be doing. I don't know. So what we do here is what's called cross-validation. Who knows cross-validation? And who's never heard the word before? OK, good. So we don't need to go into it. So this is basically a way of getting predictions out of our classifier without ever looking at the testing data. So we can get an approximate idea of how well we're doing without overfitting. So we do that. And I've just created, again, this is just a helper script I wrote, which shows the performance. So I've passed it the real labels from our training data and those that we predicted. And we see we get not bad, actually incredibly good, 91.8%, which is nice. And then this is a confusion matrix. So this just shows, so these are the true labels on the left, and on the horizontal axis is what we predicted. So there were 552 that were news, and we predicted them as news, but 13 of them we got wrong and predicted as clickbait. And vice versa, we got most of the clickbait, but a few of them we actually said was news. So you can see we're worse at distinguishing news from clickbait as we are from clickbait from news. And so we ideally want a strong diagonal in that matrix. And in a multi-class problem where we have more than just two things that they could be, then it's the same concept. This will be larger, and you want high scores on the diagonal. Is that clear? OK, good. And it's also a great idea to have a look at where we went wrong and see if we can get some insights into what happened. So these ones are all wrong. So you can assume we predicted the opposite of the real label. So only a true pop culture nerd will recognize something. OK, so this definitely should have been clickbait. So something's going wrong here. And again, it's probably something to do with our limited vocabulary. Probably we didn't know that nerds was meant to be clickbaity, for example. OK, so not much here, but do always look at your misclassified samples to get some information. This is all part of the model selection process. OK, so now I think we're just going to start trying to improve the model somehow. So we've got 91%. We'll see if we can push it up a little bit. So the first thing, and maybe let's move quickly through this. Instead of training, do you remember last time I took a pipeline? I trained it on the titles and their respective labels. Now we're going to use title and description. So in general, this is a good idea. We're giving it more text. It should definitely do a better job of predicting. And I've just printed the performance again after that. So now we get 90. Is that the same? OK, yeah, cool. So we've gained 1.5%. So you can actually see that often, and I think this is another good lesson, the cheap and dirty approach, as I've sometimes heard it be called, can often get you a long way towards decent performance. And then at some point, you have this tail of performance, which you have to put a lot of effort to push that way. Now, of course, that's the difference between the sort of masses and intellectual property or really high value. But if you're just trying to throw something together, I would say once you get to like a certain point, you can call it a day, and you don't need to keep pushing. And we're seeing that exact thing here. We're going to add a bit of complexity, but we really don't get that much for it. But of course, if you're Google versus Amazon, those 2% make a huge difference. Something else we can do is use a TF-IDF vectorizer. Who's heard of TF-IDF? OK, so this has been a slow workshop. So the count vectorizer counted how many of the words appeared in each case. In the TF-IDF, which is term frequency inverse document frequency. OK, nice and good, more nodding. So the TF-IDF vector just weights those words according to how rare they are. So for example, if something says and a lot, at the moment, something scored is very relevant just because it appears a lot. So if you have the word dog appear twice and appears 10 times, then it's kind of like, oh, this must be very much about and. But and is very common in the English vocabulary, and dog is less common. So what we should do is weight that and say, well, actually, and often appears very, very often, so that comes down, whereas dog doesn't appear that often, so that becomes more relevant. Does that make sense? Cool. And so we just use that. All I've done is recreate the pipeline steps, and I've dropped in TF-IDF instead of the count vectorizer. And we squeezed just under another % out of it. Nice. And you can see we're actually doing a better job at reducing these misclassifications than these. I think this was 12 before. And something else, which I actually did on the train here this morning, the vectorizers take this kind of preprocessor function. So before you do that text to numerical data transformation, you can preprocess all the strings. And you saw before that one of the features was 21, and I was saying, well, probably numbers in general are a good feature. So all I've done is I've written this function called mask integers, and this takes a string and returns a string, so that's all that you have to write for the preprocessor, as long as it takes one string and spits one out. And I've used a regex substitution. So all I do is search for a set of numbers in a row, integers, and then I replace it with this word int mask. So I could do mask integers 456 camels laughing, and it turns it to that int mask camels laughing. Okay, so why is it handy? Because we think that numbers in general are a useful feature. So what we do is we just represent all numbers as this word int mask, or anything you want. I just don't think int mask would come up in any of the samples. And the idea is that 17 camels laughing against 15 camels laughing are really no different in our concept of like why that is a useful feature. We think it's useful because BuzzFeed puts numbers in a lot, and the Daily Mail uses less. So I do that, and all I do is I recreate this vectorizer, but I just pass the preprocessor like that. And again, you saw earlier there are so many interesting options, and I definitely recommend on the train home or whatever, go check out what all of these do. They're really helpful, and they just save you so much coding. Often, if you have an idea, a kind of function sort of exists. It's like it learns to do it already. So we've hey.
Changing that to odd and even. I've heard that they often use odd numbers, as in you only need the 21 octopuses I found.
Oh, really?
Apparently, but it actually may actually go down by 0.2.
So it got worse. So
yeah,
you,
it got worse.
Okay, that's interesting.
But,
So
yeah.
oh, very nice. So how did you? So did you extracted the number out?
Change the second argument to sub to a function that passes the number and returns odd and even.
Oh, okay, cool. Yeah. Oh, very nice. So great idea. So the way it went down.
It went down.
But the theory is that BuzzFeed uses odd numbers. That's what I've heard. Okay, that's interesting. I actually find if I'm like adjusting the volume on something, I always go to even. So I don't know if it's related to that or not. I don't know. Okay, so that's that. Cool. Everyone following? I think so. Good. And the final thing we're going to do is we're going to play with some hyperparameters. So these are, you can see, actually, we sort of already used, in a way, a hyperparameter. Here, or previously, we just used the default settings. We created this SVC and the vectorizer, and we didn't pass any arguments. But there are things, such as, the question came up earlier, the trade-off between how much we allow things to cross over the line in the vectorizer, and we also have various other options. Oh, sorry, that was in the classifier. We also have various options to choose in the vectorizer. The question is, how do we do it? And we do something called a grid search. So I'm just going to recreate this pipeline again. Again, I'm going to use the default parameters. All right. I create the pipeline, and then here I create a dictionary, right? So the structure of this is, who's seen this before? Okay, only a few people. Okay, cool. So the structure of it is, these are basically parameters we want to vary in the constructors for our objects. So when we create the vectorizer and the SVC, for example, we don't know whether the mask integers thing is actually useful or not in the end. I mean, well, okay, we do. We could run it once without and once with. But how about if we change other parameters at the same time? And so we might also want to try odd and even, as well as just one that replaces numbers. And so what we do is we give the name. So the key is the name of the step. Do you remember we named the steps here? Vectorizer classifier. And then the keyword argument for its constructor. So do you remember last time I created it with preprocessor equals mask integers? So you just pass that here. So what we're saying is we want to vary these parameters in the classifiers. And what it's going to do is, when we fit it, it's going to make a model for every single combination of all of these parameters. Okay, so we try, this many times this many times this many times this many different models, and it's going to train them all and tell you which one of those was the best. It's a bit of a brute force approach. There's no clever optimization going on. You just compute all of these models and pick the best one. And so some things I'm varying here is stop words. This is sort of like a white list. So these are words, a black list. So these are words that you want to ignore. So it's often things like it's and the aren't that informative, so we just want to strip them out. And scikit-learn has a dictionary called English, and that will just remove like very common English words that things aren't very useful. So we'll try stripping those out. I'm going to also try none. I'm going to try my masking integers, and I'm going to try it without. I'm going to vary this parameter c, which we were talking about earlier. So this is just a hyperparameter for the classifier. And also the n-gram range. So this is quite interesting. When we did this tokenization, so we split the words into numbers, it was just on a per word basis. But we could also, so they're called unigrams. We could also do bigrams, so we could chunk blocks of 2 words. And the idea is that we managed to give some context to words after that. For example, I don't know, fall down and down are kind of like 2 quite different things. So we can use both. And so here we use just unigrams. Here is unigrams and bigrams, and here just bigrams. So I'm not going to go into too much detail about it, but we'll try it.
Can you just remind me, what's the pipeline model again?
The pipeline, this.
Yeah, no, because you're running everything, you're doing the grid search on the pipeline, right? What's that again?
Sorry?
You're doing your grid search on the pipeline model.
Yeah.
What is the pipeline thing again?
So the pipeline is just the combination of the vectorizer and the classifier. You remember it's just a sort of larger box containing 2 smaller boxes. Okay. Maybe I'm avoiding technical terms too much and just confusing you. I don't know. OK, so then we just call fit the same way. So I've created this grid search object from the pipeline, but it behaves very similar to the pipeline. We just call fit on it with the same data. I've passed it the full content and the label. And now you can see it's actually taken quite a bit of time. And it spits out some debugging type stuff. Sorry? Yes. In fact, I must have anticipated your question. So there's this thing called n_jobs, and this is like how many cores you want to use to run it. So scikit-learn already does parallelization for you. How useful. Although I do just want to give a caveat. I once had a really complicated pipeline, and I got a race hazard, and it all locked. So I don't know. Keep your eye on the scikit-learn. It's still in beta, right? So keep your eye on the bugs, but it does sometimes lock. But if you set number jobs to -1, that will use all of your cores available, all right? So that makes it go fast. So actually, if you don't set that, it might run quite slowly.
So if it locks, what's the optimal number? 1?
Yes, sorry, it defaults to 1. Yeah, so I've never had problems on that. But I've had it set to -1 in a script, and I deployed it somewhere, and it was horrible. So yeah. So yeah, maybe don't use it in production yet. I think this is one thing we forget. It's true of pandas as well, is that they're both technically in beta. The user base is so big as we think of them as stable, but they seem to have no qualms with changing the interface and not having it being backwards compatible. And either we've all felt the pain, or there's a developer here and now they hate me. I don't know. So yeah, I've definitely felt the pain, and it's still true in scikit-learn. So why did I just execute that again? Okay, we'll wait. And then what we do is we fit the object, and then out of the other side, we can just get out. We can look at the best parameters and the score associated with it. So if you imagine we built this grid of parameters, and at every grid point we trained a new model, and then we just look at all the scores and pick the best one. And so let's see what we get. OK, so the best value of C was 1. There's no real physical interpretation to that C value, by the way, but you do almost always want to optimize it and find the best one. So I find a good way is to start at like 10 to the -5 and go up to 10 to the 5, and then you can hone it down a little bit. It turns out that the bigrams were not useful, so you can see that we have unigrams only. What else have we got? Oh, the preprocessor. Turns out our mask integers thing was useful, so it's said that that's a good idea. And it hasn't used stop words, which actually I think isn't surprising. Probably the difference between clickbait is actually a lot in those really small grammatical uses. Because we're basically trying to find a difference between, like, OK, I was going to about to say good and bad journalism. I don't know. They're like 2 different styles of writing. You know, it's not so much a topic. So I really think those words are important. And the best score we got was 96.5%. Quite nice. OK, so usually, you might be doing this for several days or something like this, but the idea is that we had that testing data locked away in a drawer. And there's always this danger that you've overfit to the data, so you've picked your model to operate perfectly on your training data, and when it goes into the wild, then it's going to perform poorly. So we can do this final sanity check and see how we do on data that we've never seen before. Okay? So all I do is I call pipeline. I go to our grid search and ask for the best estimator. That's just a helper function which stops you from like having to recreate the pipeline with all these best parameters. They've already done it for you. So you grab it, and then all you do is predict on the testing content. And we see we actually do really well. I was really pleased when this came up, actually. I ran it last night, and I was happy. That could have been a major embarrassment. So it looks like it generalizes pretty well. And actually, we've done slightly better than we did on our best training data. So that's quite nice. All right, any questions? No? And how long do we have? It's till 10 past.
Yeah, I think we should have some time for this and more stuff.
OK, cool. Let's do that. So one feature of scikit-learn, which if you've been using it for a while, you might not be aware of, but I find is like a very overpowered feature of it, is that the pipelines are pickleable. So when you've trained a pipeline, you can save that whole structure with, yeah. Sorry? How can you pickle it, did you say? Oh, I see. Yeah, yeah. OK, so I don't know that much about the element of it. But so, yeah, you can. So I just use the pickle thing. Are you saying there's a better interface for doing the pickling?
Yeah, it's built into scikit-learn.
Ah, OK. I didn't know that. So there you go. But I've just used the pickle thing. It seems to work just as well. So the idea of pickling, if you're not familiar, is just that you can dump Python data into a file, which is great because you can persist stuff. So what I've done here is, now again, here's some good practice for you. Version your classifier. So we'll call this version 1, the first one we ever built. And it's going to save all of the data and the parameters and the model. OK, it's not all that distinct into the way it's saved. But you can imagine that everything that we've trained this on is kind of all chunked together in one file. And so I'll just do that here. And we've dumped it to a file. And so there are lots of things you can do with it. That's the end of the kind of main part, but we do have more to show. Does anyone have any questions on what we've seen, on pickling, on any step of what we've done? Sorry? I didn't hear, but should we do it? Although, wait, this might run really slowly now. So what happens with the gamma parameter? This is in the classifier, right? Which one are we referring to here? OK, yeah, sorry. So yeah, we're limited. Yeah. So the full SVC has some more options, like the probability. Yeah. OK, good point. And sorry for the confusion. But yeah, we can chuck lots in there and do it now. And actually, what I've done here, so if anyone who isn't familiar, if you understand SVMs but you haven't used the scikit-learn interface, they have linear SVC, which is like a support vector classifier with a linear kernel. But they also have a more general SVC. The only difference is the numerical method that's on the back end. So if you're going to use a linear kernel, in general, you should use linear SVC. But you can use the normal SVC and specify linear kernel. And it uses a more generic numerical optimization on the back end. So it has more parameters to fiddle with, more options. All right.
It's a bit slower.
Yeah, is it?
Yeah.
OK, that makes sense. So there's the trade-off. More options, a bit slower. Out of the end. But I think you can actually use the probabilities that come out. You can use a probabilistic model in that case and do it. But yeah, this is a good point. OK, so that's there. OK, there's two other things that we can show you. And these are just based on what we might do after we've saved our classifier. And I always like to think of things, again, from the sort of client perspective. And so you think if you're doing this for intellectual property or something, you can pickle the classifier, and you can hide that behind some sort of function, or you can hide it somewhere into a binary, or you could hide it behind a REST API even. And you can kind of keep the data and the way that you've trained everything, but you can expose the predictive power of the model to somebody else. Okay, maybe that resonates with some ideas that you guys had in mind. Hey, yeah, encrypt it. Anything you like. So, did anybody move on to this already? Did someone come up with some interesting statistics? Because it's very sparse. Okay. Oh yeah, thanks. okay, so all I did here, this was just starting to fiddle around with the prediction. So I'll import pandas, and there's another CSV called all data. So in the last case, we didn't have the source available, just because I wanted to keep things simple. But now you can play with it as much as you want. So we have the source there. And so you can see, okay, yeah, again, there's that literally just 19 pictures. And now we can actually see it's from BuzzFeed, which I'm sure you guessed. But it's there. And so we can import our classifier, which is versioned. Oh, no.
Kind of happy because I got the same error. So I was wondering if you were going to get the error.
Yeah.
I know why, because functions are not really.
Really?
Yeah, so maybe try to just define this function in this iPod.
What, so if I, yes.
You define the mask integers function.
Oh, yes, I did it in line.
So just define this mask integer function in the second notebook as well. Probably will work.
Have the rest of you also followed? Did anyone foresee this happening? So the reason is, as I said, I added this on the train this morning and obviously didn't fully test the rest of it. Very foolish. But it did make the journey go faster. Ah, okay. Oh, but it still worked. How bizarre. Oh, because it hasn't run yet.
Yeah.
All right. So, I mean, is that going to work? Oh, we're about to find out. So the data's a little bit messier in this case. So I basically am replacing the description title and text columns by replacing the values that are nan. What's jumping around? Okay, I thought something was breaking. So where there's missing values, I just replace them with an empty string because that's at the moment it's probably the best way to handle missing values. So that's just tidying up the data a bit, and we can go to the top again. And okay, I'm not going to use the published at field for now, so it's the same. Okay, and then all we have to do is we loaded the classifier. I actually really don't know if this is going to work now. Okay, yeah, it seems to be working. Cool. So we just create the predicted labels. And what I've done here is I just assign a new column to the data frame called label. And so you realize in this case, actually the training data is contained in here. So yeah, I'm cheating a little bit. But we didn't have the label. So you can imagine we didn't know whether this stuff was clickbait or not. But now we've actually predicted. And here, we should actually expect, because these appeared in the training data, that they're going to be correct, right? But there are those that weren't in there. Okay, so what can we do? So one thing I did here. Oh, okay, so I get our data frame. I group it by the new source, which is now available to you guys. I get the label out, and I sum it. So this is the total number of things that were predicted clickbait for each source. And because there's actually I think we have barely any from the Financial Times, but loads from the Daily Mail, for example. I've also normalized here, so I also group again by the source and just count the number of samples there are. Does that make sense? So you get the BuzzFeed, and it's like so we end up computing the proportion of clickbait for each one. And then I'm going to plot it on a horizontal bar chart again. And here it is. So BuzzFeed, unfortunately, is very clickbaity. I'm actually not completely familiar with all of this. Does anyone read The Verge? Is it true? Is that a good amount of? Yeah, it's about right. I think Mashable, I've definitely been trolled by them, so that's not bad. The Metro, maybe more than I thought. Al Jazeera, none. Financial Times, also none. So actually, the other day, and as you can see here, before the model was finished, I think before I did those extensions, the Financial Times actually had quite a few apparently clickbaity articles, but I seem to have removed them. So that's actually I'm quite happy with that. Although it does ruin the next bit of demo I was going to give you, but anyway. So yeah, that's there. And it actually turns out that TechCrunch is also quite baity. I think that's actually true. Yeah. Do you think that's fair? Okay, yeah. Did anyone, so that's the end of this one. Did anyone try anything else here? Did you get some insights? No one made it to the advanced notebook? I suspect some of you did. You just weren't bright enough to get something interesting out of it. Yeah, well, I couldn't, so I'm not surprised.
You want to show the service as well? So basically, you can use string data.
Yeah, so let's do that. So and in case you guys want to go away and also build something based on news, or you can put this on your blog or whatever. This is awesome. this is free, and you can just sign up, get an API key up there. It's immediate. You just have to give them your email address. And this is a REST API that you can query, and it has, look at these, all of these news sources available to you. You don't get the full content, okay? You just get the title, the publish time, things like that. But it's nice if you want to show headlines on your blog or your website, or you want to scrape it like I did for some machine learning. And we found out today, actually, that the title and description is enough to do some useful stuff. So that's actually quite cool, I think. But because some of these are paid for services, they don't give you the content. The URL is newsapi.org. Sorry, you can't see that, but there's the name. newsapi.org. And in the, so that's the end of the notebooks. In here, I've got a folder called, a directory called web service. And if you go in there, I built like a really quick Flask app, visually very unappealing, but the functionality is there. So let's just take a look. OK. So I've created like some HTML that we're going to show in the browser. And then I have this function. Now, I didn't actually have time to do exactly what I wanted to do here. But you could put this behind a REST API, right? So you could make this a post request or get request. And I don't know what actually would be best if you retrieve a label. What's the standard? Predict? But you can't make like a predict request. I'm thinking like, nobody knows, so it's open. I tried to find information on this, I couldn't. So let's say we make a get request. So you, or post, no, yeah, we'll do post. So what you could do is that you could have a URL, and you post a JSON to it with like your information in, and then it will just spit back a label. So this is really nice if you do want to hide all of the backend from somebody. You just want to expose the predictive power to them. Then you can put it behind an API, and you send titles to it, and it will just tell you if it's clickbait or not. So that's really nice for a web service, and it keeps your front end all light and your web servers really light. And somewhere, for example, on AWS, you could have some scalable stuff. And they actually sort of do that with their Lambda function. I don't work for AWS. So that's there. So all I do is every time, and I'm kind of sticking with the idea that it's stateless. So every time you call this, I like load. Maybe this is a bit unnecessary, but I load the classifier from scratch, and then I predict on it. All right. So this should always return the exact same thing. And of course, you can version it as well, and you could version your API. So you could say, you can query my version 3 API, or you can use the version 1, and you can store that as metadata. And these things were built with the version 1.1 and the version 3. This is all important for testing later. Once you've predicted tens and tens of thousands of stuff, at some point you're going to want to know, like when I deployed version 3, was it actually any better when it was in production? So this is really important to version your classifiers. So later on, you can back work whether the work you did was actually useful or not. Clear? Great. So I've got that, and then here I just make a request to that news API. I've given an API key, I check that it's all there, and then here I just add the title and description together that I get back from the request, and then I grab the label. Okay, I see people are clearing out, so we're almost done. That's it. I think I can. You need to export some environmental variables to make this work. First time. Is this right?
Yeah. You need to define the.
Oh, yeah, this dependency is missing just the people install request.
Nice.
Oh, not that this.
I think they sponsor the conference, right? So I'm obliged to do this. Yeah, it should have been in my environment file. Oh, it's in core Python. Maybe I just didn't import it. Oh, it's not. OK, thank you. Oh, sorry, I don't have the full Anaconda distribution. Just Miniconda. Oh, it's there. It's working. Quick. No.
Mask integers, the same. It's for Python. It's mask integers, the same.
Oh, I don't believe it. Oh, actually, I do. I absolutely believe this. What? Yeah, it turns out I was like, wow, I can't believe that went so well. People usually say this is a terrible idea, but it seems to work great. There was some motivation to myself there or something. All right, let's try this.
You need to import regex as well.
Oh, yeah.
OK. we think it's going to work? Oh, so, okay, it's to do with this mask integers thing. I'm just going to quickly get rid of that. You know why? Have you figured it out?
Yeah, it expects it in Flask, not in namespace.
Ah, okay. So sorry, everybody, for the little anticlimax here, but I'm sure you saw what was going to happen. I'm going to pull down live the articles from the API, predict on them, and then serve them up in not a prettified format, but it's there.
Should have used a different version.
Yeah. So let's just get rid of the preprocessor option. Yeah. Yes, I should have. Who just said that? I should have created another version of the classifier. Very good. But I haven't. This is exactly what I just said don't do, for the sake of speed.
You just add app.run at the end of the file and just run it.
Oh, so you've just fixed it?
Yeah.
Oh, well, there you go. It's over. We're gonna run without it.
But what are we looking at? What's the result?
So the result is, oh, so you've got it.
Timer causes mayhem. So
Somebody causes mayhem. Oh, right, great. So you've got a better version than I have in yours. Nice work. Actually, I want to see that afterwards. Okay, so all this is, and again, I know it's quite ugly, and I was hoping to have various news outlets here, but I've gone for Daily Mail. It's grabbed the titles live from that news API. So these are the 10 most recent articles published from Daily Mail, like really up to the second, or when I loaded the page. It's not responsive. I mean, it's just, you have to refresh to update it. And then it's taken that, sent it to our classifier, which we made in the notebooks and stuff, but we pickled it down. And then it's called it, it's loaded it, predicted, and then I've just added is not clickbait or is. And it looks like everything here is not clickbait. Maybe that's reasonably fair? I think it is. OK. What a shame. There should be a mix. But, but this is exactly the sort of thing you can do. So I think that's basically the end. So if you have any questions or you want to speak to me afterwards, then let's do it. But otherwise, the coffee queue is getting big. So get in there.